Hello, this is my research project and I'm going to explain what AI sensory is. AI sensory refers to a mechanic that allows AI characters to perceive their environment through various sensory inputs such as hearing, touch, proximity. Unlike sight, which is implemented using perception cone and a line of sight check, other sensory types uh, can detect stuff like light or not like it can detect sound, vibrations, and other non-visual cues. Uh, Unreal Engine provides this in the framework, enabling developers to develop intelligent NPCs to react dynamically to their surroundings. The most common sensories are like hearing. You can make the enemies like detect if a sound is being played from a certain location. Uh, Proximity checks, they can detect if an object or a player is just near them without visual detection or like collision, or you can make custom events. Ways of learning it, Unreal documentation, specifically the sensory for AI perception and custom event. YouTube tutorials, there's a lot of YouTube tutorials that can cover AI censoring. Epic Learning Hub found examples to how of like other people using AI censoring and just generic trial and error. The best demonstration for data sensory is like in stealth games. An AI can patrol an area and react dynamically when they hear sound, like a player throwing an object or when the player comes too close. Pros in using it: highly modular and customizable. You can customize whether or not a AI can see you but not hear you but not see you, can detect if your general presence in a vicinity or other means. It can enhance the immersion of your game, making it more realistic, and it integrates well with other AI systems. The cons is it can be very resource intensive trying to simulate these things. It requires some fine tuning to ensure that there's not a false positive, and there's quite a learning curve. The best practice is to combine senses so that you can make the AI behavior behave to how you like. Combine like the hearing to like, oh, what's that sound? Goes to that general location to where the player is, and then when they see it, to change to a different state. Optimizing it, you have to limit the sound and hearing, the sound collision range and seeing range in order to make it function and not crash the game. Debugging, you got to make sure that the AI can hear and see you properly, and just balancing balancing the AI to make it just fun and fair. Here's like a step by step to implement, and I'm going to show off what I have. So what I have is just a modified version of an old AI project I had. So, and here, this is the tree. Here is a sequence for attacking if the player's in range. Here's one for the sight, and here is for the hearing, which is very similar to the sight. And this is a normal patrol path. In the AI, in the enemy controller, we have a AI perception, and we gave it a sense of AI hearing config, and gave it a sensing hearing. This is the hearing range, how big it is, and it can detect enemies, neutrals, and friendlies. And if we turned on debugging, we would see the cone here. Yeah. This is the AI censoring. It triggers getSense class for similes. It returns the value to being AI sense hearing. Checks if it's true. If it is, return. This is just a reuse from this here from being able to see, but it triggers the same way. It's pretty much if we can hear the player, trigger yes, and then what is the actor that we're going to go towards, and then set the vector and set like the location vector to being where the sound came from, and then print a debug. And if it can't, do pretty much the same just to ensure that it doesn't break. Yeah, and that's also in player. We also have an emission. So every time the player jumps, it will trigger like a noise event, which pretty much means like because we don't actually have a sound effect, we need a way of detecting if a noise is being played. So this is to just show like, hey, when the player jumps, emit a sound of some kind, and then this is a debug checking if it actually triggers. So yeah, I'm gonna show that off. So go over here, enemy's walking, but if I keep jumping, see that it's like detecting, and boom, it's now following and it's now following me because it was able to hear me, and it's now colliding with me. So yeah, that's my research project. That's a demonstration. You can use this. An example of using this in a game, you can have like a stealth game where you want enemies to hear you, but you don't, like if you drop something or you throw an object, it hits, and you want the enemies to react to the sound, not seeing it. And then there's another instance of like, not to use it, and then an instance of not using it if you want like, if you have like a game where you need to give voice commands to units, but you don't want the enemy to hear your voice. That's like an instance of not wanting the AI or the enemy to hear your voice. So yeah, that's my research project, and I hope you enjoyed.